here it simply shows all the files. One of the first file you need to look at is a readme.md. MD is a markdown format. So this is a completely text format, but in a special keyword so that you can, so that this readme is shown so that it can be directly shown in the web page like this. So this readme is shown in here. So let me briefly go over the features. You can do Hartree-Fock and DFT theories for the ground state properties. And you can do excited state properties by TD-DFT. And you can do both ground and excited states using these two theories. So we have 1, 2, 3, 4, 5 theories. Using this, you can do geometry optimizations, transition state search, conic intersection search. We also use external software to do this. You can also do Hessian calculations. So you can do geometry optimization of any states, like ground state, excited states, any states you can perform these. Also, it eventually generates the Molden file, separate Molden file to support visualization, which I will also demonstrate. So which can read by many graphic softwares. So you can see what you have. And DFT D4 dispersion correction is kind of fancy and popular these days. This is developed by the Professor Grimm. And most famous one is D3, now it's a D4. So basically you can consider this as adding extra accuracies to the DFT calculations, which includes dispersion, long-range dispersion corrections. And libxc integration simply means that you can virtually use any kind of exchange correlation functionals available in the literature, because the libxc is a library that has that collects all these exchange correlation functionals. And also it has a Python layer, so you can easily use, if you know the Python, you can modify our basic run script for your own study. And this is well parallelized. So if you have a multi-core CPU, for example, if you have 8-core, 16-core CPUs, that it will utilizes all of them. So that's quite good. And we are working on these 3 additional ones, like non-adiabatic coupling, which everybody's waiting for, because once we have this, we can connect this with the non-adiabatic MD softwares like Newton X, Shark. Everything can be connected because they all need this. We already also have a spin-orbit coupling theory because we developed a relativistic version of our theory. So we will also try to implement this. So with this, we are trying to study the intersystem crossing process too. So non-adiabatic is for the internal conversions. And also, we also developed the EKT MRSF TD-DFT theory, which can calculate the ionization potentials and electron affinity. Why this is important? Then we can simulate the XPS and UPS by using this. So this is these are things that we really want to add here.